Hello everybody, I'm Murat and I will talk about methodology and performance for database management system. Design of database. The first task of a database designer is to produce a conceptual data model that reflects the structure of the information to help in the database. A common approach to this to develop an entity relationship model. We need to establish definition and definitions of the terminology used for entities and their relationships and attributes. Producing the conceptual data model sometimes involves input from business process or the analysis of workflow in the organization. Having produced a conceptual data model that users are happy with, the next stage is to translate this into a schema that implements the relevant data structures within the database. This process is often called logical database design, and the output is a logical data model expressed in the form of a schema. The logical data model will be expressed in terms of a particular database model supported by the chosen database management systems. The most popular database model for general purpose database is relational model. The process of creating a logical database design using this model uses a methodical approach known as normalization. The goal of normalization is to ensure that each elementary fact is only recorded in one place so that insertions, updates, and deletions automatically maintain consistency. The final stage of database design is to make the decision that affects performance, scalability, recovery, security, and the like. This is often called physical database design. A key goal during this stage is data independence, meaning that the decisions made for performance optimization purposes should be invisible to end users and applications. Physical design is driven mainly by performance requirements and requires a good knowledge of the expected workload and access patterns and a deep understanding of the features offered by the chosen database management systems. Second, general views. A database management systems provides three views of database data. The external level defines how each group of end users sees the organization of data in the database. A single database can have any number of views at the external level. The conceptual level unifies the various external views into compatible global view. It provides the synthesis of the external views. It is out of the scope of the various database and users and is rather of interest to database application developers and database administrations. The internal level is the internal organization of data inside a database management systems. It is concerned with cost, performance, scalability, and the other operations matters. It deals with storage layout of the data using storage structures such as indexes to enhance performance. Occasionally, it stores data of individual views computed from generic data. If performance justification exists for such redundancy, it balances all the external views performance requirements possibility conflicting in an attempt to optimize overall performance across all activities. Three, performance. There is five important topic, and these are storage, security, transactions, migrations, backup, and restore. First, storage. Database storage is the container of the physical materialization of database. It comprises the internal level in the database architecture. It also contains all the information needed to reconstruct the conceptual level and external level from the internal level when needed. Through typically accessed by database management system through the underlying operating system. Storage properties and configuration setting are extremely important for the efficient operation of the database management system, and those are closely maintained by database administration. The database data and the additional needed information, possibly in very large amounts, are coded into bits. Security. Database security refers to the collective measures used to protect and secure database or database management software from illegitimate use and malicious threats and attacks. It ranges from protection from intentional authorized database used to unintentional database access by unauthorized entities. It's a broad term that includes a multitude of process, tools, and methodologies that ensure security within database environments, which we will discuss later. Transaction. Database transactions can be used to introduce some level of data integrity after recovery from a crash. A database transaction is a unit of work typically encapsulating a number of operations over a database. Each transaction has well-defined boundaries in terms of which program code executions are included in that transaction. Migration. A database built in one database management system is not portable to another. However, in some situations, it is desirable to migrate a database from one database management system to another. The relations are primarily economical, functional, and operational. The migration involves the database's transformation from one database management system type to another. Thus, the database's conceptual and external architectural levels should be maintained in the transformation. And the last one is backup and restore. Sometimes it is desired to bring a database back to a previous state. To achieve this, a backup operation is done occasionally or continuously, where each desired database state is kept within dedicated backup files. When this state is needed, these files are utilized to restore that state.